Welcome to the Intelight tutorial 103 on max time sequence logic. Sequence programming is one of the very first things I like to program inside the controller. I get my sequence right, the rest of it goes a lot easier. So you go to controller, go to sequences, and in sequences, because it's NTCIP, you have up to 20 unique sequences. Each sequence can have up to 16 rings, which is a very flexible ring structure. And of course, max time has 40 phases. The first rule in programming a sequence is the comma rule. We use the comma as our delimiter to separate phases and barriers, and you have to use a comma. The comma rule is very important. You have to use a comma, not a period, not a space. If you didn't have the comma between phases 1 and 2, it thinks it's phase 12. So make sure you use a comma to have a valid sequence. This is a very important section in max time. I'll blow it up here so maybe you can see it a little bit better in the video, up to maybe 150%. So as you see, it's a phase, a comma, a barrier. The next rule, rule number 2, is the ending barrier. So in each ring, the last character should be a letter, which makes it a barrier. So therefore, it can progress back to the beginning of the ring. The ending barrier is the last character of each ring, as I stated before. Try to blow this up for a little bit bigger for you. But if I had a 4 ring or a 5 ring, it doesn't matter. It's the last character, this B character, in our case, it could be C, D, E, F, but it has to be a letter at the end of each ring. One of the first or basic operation of sequencing is to do lead-lag operation, where you may want to lead the 2 left turns, or lag the 2 left turns, or lead one and lag the other. And that's what sequencing starts out. Lead-lag sequence is often called alternate sequences or phase reversal. So before NTCIP, we would have a ring structure and we do alternate sequences to do the phase swapping. In NTCIP, we just pick a different sequence to use. So we have our 20 sequences, we define them. We can select these by pattern, and the pattern can be by time of day. And it can be a free pattern, so you can do it under the free operation. In this first sequence is a standard 8-phase quad, 1 and 5, 2 and 6, 3 and 7, and 4 and 8, where ahead of the A is Main Street, and between the A and B is the side street. If we go to sequence 2, you notice that I have reversed 1 and 2. So this will come up and run 2 and 5, and then 2 and 6 will run because 2 and 6 are bigger, and then it go 1 and 6, cross the barrier to the side street. If I went to sequence 3, and I dropped it down and picked sequence 3, you will notice that I've done the lead lag on the side street. So the main street is my normal lead operation, lead lag on the side street. Now I have these programmed in. You can program to be whatever you want them to be on whatever number, or you can set them up to have them standard in your default database and always peak. Sequence 1 is a lead, and sequence 2 is a lag, so it gives you some flexibility. Notice here I've reversed the second ring. 5 and 6 have been reversed. So it's 1 and 6, 2 and 6, and then 2 and 5. This is called the phase reversal alternate sequence. In NTCIP, we are just picking a sequence as you define it. Rule number 3 is no empty clusters. A cluster is a set of phases between barriers by definition. And we cannot right now have a blank cluster. The no empty clusters means that we cannot have an empty spot between the barriers. So a cluster would be 1, 2, 5, and 6, and the second cluster would be 3, 4, 7, and 8. So you cannot remove these phases completely. So I cannot go in there and delete phases 3 and 4. I cannot have an A comma B comma with no phase in there. It can be any phase. It doesn't have to have an output. It doesn't have to have timing in it. It could be a dummy phase like 9 comma B, that's legal, or 39. It just cannot be something between it. You cannot have a comma blank and leave the B off. It doesn't work. So certainly we may do things differently in the future, but for right now you need a phase in there. So whether it's the leading cluster or the second cluster or a different ring, you just need to have a number in there. So you could put in multiple phases. I got 1, 6, 9, 10 comma. That's a good sequence. But you cannot have a blank one. A comma B comma is not valid. A B is not valid. You have to have a number in there. So how do we do split phasing? So we will do that next. Split phasing is when we have the side street and we want to run them separately. So one side of this side street will run and then the other side will run. So we might want to use 4 and 8 as our 2, 3. Split phasing is where you're going to run the two side streets separately. So if we want to keep our phasing consistent, we could make our through movements 3 and 4, but typically the even numbers are our through movements. So I will move phase 8 to the first ring. So it will run 1 and 5, 2 and 6, cross the barrier, run phase 4, and then run phase 8. I have to have a phase in this lower cluster, but it could be phase 7. So this is a valid split phase intersection. It's the easiest way to do it. If you don't want to use phase 7, you can make it phase 17. It doesn't matter. It just needs to have a phase in there. Just don't assign a detector or don't assign it to the load switch. There's no output on it. So it's a placeholder to cross the barrier. So make sure you have a phase in the second ring to time with 4 and 8 up here. And it really has to do with crossing. The next very common sequence is a two-phase intersection, one of the simple, most straightforward intersections out there. A two-phase sequence looks like this: 1 comma 2 comma A comma. You don't need anything after the A because it's going to be the ending barrier, so it meets rule number 2. If you want to make a 3-phase, you just put a 3 comma in there. Certainly this is a very valid sequence that we use on a two-phase operation. Texas Diamond sequence has some unique detector switching and detector calling set up. So we use sequence 17, 18, and 19 for these specialized sequences. Other diamonds that are K-clearance diamonds, other diamonds can be programmed using other sequences. But if you want the true TTI Texas Diamond. Texas Diamonds have some unique sequencing. This is the TTI Texas Diamond 4-phase sequence. So we use sequence 17 to do the detector switching. 4-phase diamonds phase the boulevard. A 3-phase diamond like this one here will phase the off-ramp. So you do need to have storage if you're running a 3-phase diamond, or the intersections need to be more separated than a 4-phase diamond. And then the separated intersections where you're going to run one side versus the other is a very simple diamond. And of course you can switch these dynamically, but just use 17, 18, and 19 for the embedded logic. A K-clearance diamond is a diamond that came out of the 170 world, and we can do this in our NEMA controller to call the inside movement. A K-clearance diamond is one of the more complicated sequences that you'll run across, mainly because it has just lots of phases. You can click in and scroll over and see all the different phases in the different clusters. We basically have 4, A, B, C, and D. Phase 40 and phase 39 are the dummy phases to be able to run the phases above, but these phases are used to call the inside overlap movements. One of the real nice features of this sequence logic is the ability to omit or not have phases in the sequences when you don't want them, and also the ability to use different phases or swap them out to have different timers. Omitting phases of the sequence is just an easier programming way of doing it. You can still omit through patterns, through a phase option in a split table. But it's really nice here. So we could have our standard 8-phase quad, and then by time of day at night, we would go to sequence 2, and we could just remove phases. So if we didn't want to run 3 and 7 at night, we just take them out, hit apply. That's a valid sequence. So you don't have to have all your phases in every sequence. Certainly, you can bring it up and run the 8-phase quad, and then at night, if the phase is not in the sequence, it doesn't run, so you have just omitted your left turns. The other nice thing is phase swapping. So you can have a situation where you may want to have different timer values. So in sequence 1, we have our 8-phase quad, and say we want to have some different timer values for phase 3. So we could just go to a different sequence. We'll go to sequence 3 in this case, and we can change phase 3. We'll make it look like the 8-phase quad, so we'll put it ahead of 4 and delete it. Make it phase 13. So when sequence 3 is running, it uses the timers in phase 13. So in sequence 1, it uses phase 3. In sequence 2, it's omitted, so it doesn't use any time. And then in sequence 3, it uses the timer. So you can have different passages, greens, yellows, etc. And you would create an overlap of 3 plus 13 to put on the low switch, and it's a neat way to get some extra dynamic. Thank you for watching this tutorial. I hope you enjoyed it. Stay tuned for the next tutorial, which is subject will be startup information. Different ways, different conditions, the different logic of startup. Hope to see you then. Thank you.